Okay, now, question 2, the source is not moving. So there's something, maybe it's a stationary train sounding its whistle, whatever. The sound source is still 440 hertz, the same as question 1. The speed of sound, again, we'll use 345 meters per second just as a generic speed for sound and air. The source is not moving, as opposed to the previous example where it was. And this time, the observer. So somebody's going towards a sound source. And remember, the answers for going towards is going to be higher pitch, going away is going to be a lower pitch, just like before. Because when things get closer together, when they're in the process of getting closer together, you hear a higher pitch. When they're in the process of getting further away, you hear a lower pitch. Okay, so here's the basic equation. I just rewrote it. It's right here also. I'm going to start putting in numbers here in a second, but this is going to be 345. That's 440. That's 345. The observer is moving. Now, the observer is going closer to the source, and the motion of the observer going towards it, getting closer, that in and of itself leads to a higher pitch. Because the observer is moving and the observer is going towards the source, you'd hear a higher pitch. You're getting closer and closer. You hear a higher pitch when you get closer together, and it's the observer that's moving. So we're going to add the speed of the observer in the numerator. Now, in the denominator, it's all about the source. Speed of sound, plus or minus 0. And so plus or minus 0, get rid of that. Now, the whole denominator doesn't go to 0, just the source isn't moving. Again, you cannot cancel the v's. Don't cancel the v's because you have to do the arithmetic in the numerator or denominator first. All right, now let's put in numbers and solve this. So that's going to be 440 times 345 plus 20 all over 345. So that's going to be 440 times 365 all over 345. And that comes out to be 466 hertz, which is indeed higher than 440. It's higher just as we expected it would. If you compare this to the previous example, example 1, where the source was moving at 20 and the observer wasn't, we got almost the same answer, but not quite. We got 467 in question 1 when they were getting closer together. In this case, we got 466. Very similar, but not exactly the same. Now, the observer goes past the source and now is going away from. So let's just redraw this. Here is the observer still moving at the same speed. Now moving away from our sound source. Again, here's our sound source. Sound source, observer's going away. You know when you get further away from the sound source, when you're in the process of getting further away. This all has to do with what's called relative motion. When your relative motion is when you're getting further away from each other, you'll hear a lower pitch. All right? Now it's the observer that's moving. You have to ask yourself, do you add or subtract to make the answer smaller than 440? You subtract in the numerator. That one's pretty obvious. I'm going to subtract that. And the source isn't moving, so it's plus or minus 0, because that's still 0, right? So that's still 345. That's still 345. Again, don't cancel them. You first have to subtract the 20, the speed of the observer, and then do the arithmetic. So this is 440 times 325 all over 345. And the answer is 414 hertz. And if you compare that to the answer in question 1, where the source is getting further away from the stationary observer, that one was 416 hertz. This one's 414 hertz. Same phenomenon, very similar answers, but not exactly the same. All right.